So, when COVID hit and we moved online, we needed a way to continue having students work on labs, and we switched over to TinkerCAD, which is a simulation tool. Originally, I learned about TinkerCAD as a way for modeling solid objects for 3D printing, but they also have a way to model circuits and electronic components, including simulated breadboards or protoboards that you put components into, and multimeters and measuring devices and so on and so forth. So at this point, we're still using TinkerCAD for this course, and Engineering 270 will be switching back to actually working in the laboratory somewhere probably in the future. But for now, TinkerCAD. So if you don't have a TinkerCAD account, just go to tinkercad.com and you'll be able to sign up. I've already got an account. If you don't, you can sign up, and you can sign up through your Gmail address, and they don't send you a lot of spam or anything like that. So I'm going to go to personal accounts, and I'm just going to sign in with Google and choose an account. And here we go, we're good to go. You can do designs, tutorials, challenges. There's a tutorial you can run through and so on. But really, this is software that is kind of so intuitive. Your best bet for learning how to use this, either for the stuff we're doing in 250 or for solid modeling and so on, is just play around with it. Get your hands dirty and try some things. So let's go to designs, and let's say create, and we're going to create a circuit. And it'll give you a semi-pronounceable name up here, but we can change this. So I'll just call this demo 1. And basically, we have different components over here that we can drag and drop into this middle area, and we can put down wires and components and things like that. So let me just show you a simple example. Let's put a breadboard in here. So in your lab, you'll explore this breadboard, but if you remember from 120, some of these holes are connected to each other, and if you hover over it in TinkerCAD, you can see what the connections are. And so if we put something in one of these holes and we put something else in a connected hole, those 2 points get connected to each other electrically. And so we can build circuitry without having to solder or twist wires together. We can just plop components in here and build up a circuit. So let's just make a simple LED circuit. So I'm going to grab a resistor, and I'm going to put it here. Now these 5 holes up here are connected. These 5 holes down here are connected. If I were to put my resistor right here, I've connected one end to the other, because all 5 of these points are connected. So when I put in a resistor, I'm going to straddle that middle region, or I'm going to rotate it and connect it, say, between 2 horizontal points. But I'll put it in like that. Our LED, I'm just going to put this over here. And so cathode is the negative end of the LED. Anode is the positive end. So if we go back to our picture of an LED circuit, right, this is the positive end, this is the negative end, so this is the anode, and this is the cathode. So if I want to build my circuit, I'm going to take the cathode, hook it up to a 1K resistor, and hook the other end of the resistor up to ground. So let's take this and bring it over here. So that's the negative end, goes to this. And I'm going to draw a piece of wire. I'm going to pick a black wire for ground. And I'm going to go and just drag and drop a wire from here to this point. So I'm going to take this top row next to the black line to be ground, and the red row on the bottom I'm going to take to use as power. and I'm going to connect my two ground lines together, and I'm going to take a red wire and connect. I'm going to take another wire and connect my red positive power rails together. And let's give this thing some power. So components, instead of basic, I'm going to say all, and I'm going to scroll down and find a power supply, and it's set to 5 volts. So let me put that over here, and let me make some power connections. So I'll connect that in to 5 volts, and then I'll connect this end to ground, make that black, and you can, neaten up these wires as much as you like. So there's a basic power supply going in, and then our circuit was, let's come from our circuit into the positive side of the LED. So I'll just take a wire, and let me switch to a neutral color like green. Let's just take this end of the LED and connect it up to 5 volts. Alright, so what do we got? We've got a power supply. 5 volts comes in here, goes down this wire, that goes into the anode or positive side of the LED. The negative side of the LED goes through a 1K resistor, right? It's set to 1K. And the other end of the resistor goes to ground, which goes back to the ground of the power supply. Alright, so if I want to simulate this, I can say start simulation, and when I run that, you can see the LED turns on. Now, if I drop the voltage, 4.4 volts, it's still on. Around 1.7 volts, it goes off. There's 2.5 volts. You can see the LED's on a little bit. And 4.8, it's on more. And if I crank it up quite a bit, 30 volts going in, I get a little exclamation mark here, which is telling me that I'm putting in too much voltage. I don't know how to make it show a message, but it's alarmed by that. So let's bring this back down to about 5 volts. Alright, so what about this resistor? What if I change this resistor from a kilo ohm to 1 ohm? Well, you can see my LED blows up. Right, current through the LED is 400 milliamps, while the absolute maximum is 20 milliamps. Right, so I've got 1 ohm of resistance, I've got 5 volts coming out of here, I've got 400 milliamps. That's too much for the LED to handle. Now on the power supply, I can cut down the current, but that's not really the way to do this, right? So we put a current limiting resistor. If we make it a kilo ohm, that's a nice amount of current. It's pulling out about 3 milliamps. Now if I make this resistor bigger, if I make this a mega ohm, well, there's so little current flowing through my LED that it doesn't light up. So kilo ohm is the right amount. And that's probably the most sophisticated calculation we have to do, is just 5 volts divided by 1,000 ohms. It's going to be about 5 milliamps. Alright, so we'll use these proto boards, and we'll eventually start using integrated circuits. So these chips, and again, if you want to put a chip in here, the idea is put it on each side of this middle area, because if I put this chip right here, well, everything in column 21 is connected, so this pin is now connected to that pin, right? So to be able to actually connect separate things to these 8 pins, we need to straddle that middle area. And plan to spend some time making your circuits in TinkerCAD. It's worth making your wires look nice in whatever way you like. Color coding is helpful. Our circuits are going to get pretty complex. Some of them will need 2, possibly 3 large proto boards. And if everything is just kind of a big rat's nest of wires, all over the place. It can be really hard to debug, but still a lot easier than when you're actually in the lab working with a physical circuit. And so these are good opportunities to practice, you know, doing a nicely organized circuit, so that when you get to a point where you're doing this with actual devices, you've got good habits already. As we go through the course, we'll introduce the labs and get some experience working with TinkerCAD. All right, so that's the quick intro.